So thank you for joining us. My name is Spence Green. I'm one of the co-founders of Lilt, and today we're going to be talking about how to use data-driven evaluation to select a machine translation system. And what I mean by that is instead of, I'm going to advocate a method for selecting a machine translation system where you don't necessarily just put a few sentences into an MT system and then inspect the output. Instead, we're going to use some techniques that have been developed in mostly research scenarios, but they're actually the same techniques that are used to evaluate machine translation systems. And most prominently, there was a evaluation done that Google did of their new neural machine translation system last September, I guess, was when the paper came out that got a lot of press. So we'll talk a little bit about that and how that was set up as an exemplar case of a component of a machine translation evaluation. So let's see, a little bit of background on me. Before starting at Lilt, I was a grad student at Stanford and worked on machine translation for about, well, a long time, 6.5 years. And this company is sort of an outgrowth of that work that we were doing in grad school. And then also my co-founder worked at Google on Translate for a number of years, as well as our main advisor, Franzal, who started the group at Google. So we've mostly coming out of the academic community, and so I'm going to share with you some ideas today that are sort of the standard way of doing things in that community, but try to tune them a little bit to the way things are done in industry. So I hope that you come away from this with kind of a new perspective on translation quality, and one that'll help you very quickly and efficiently evaluate MT systems. So without further ado, let's get started with this. And this we're going to see if this is slightly an experiment. There's sort of an interactive component of this presentation. So you should see in the chat window in Zoom, there's a chat window, and at one point I'm going to ask you to vote on some things through that chat window, and we'll do a little experiment. So let's get started. So if you want to have a look at these slides yourself, like if you have 2 monitors up or you want to review these later, here's a link where you can find these slides, and we'll put this on social media and elsewhere later in the week. But I'll just give you a minute to copy down that URL if you want to save this for yourself for later this afternoon. All right, everybody got that? All right, let's get going. Okay, so what is the goal of an evaluation, or of this particular evaluation? So I think that, the goal of doing translation in general is to deliver an acceptable translation to a client or to somebody who's going to be consuming this information, be that somebody who's browsing a website or reading a report or trying to understand a patent. The goal is to deliver an acceptable translation, and this word is chosen carefully. By acceptable, that could be subjective. So for me, when I'm browsing the web and I don't speak any Korean, just getting some raw machine translation output might be acceptable to me because I'm not really willing to pay any money and I don't speak any Korean, so something is better than nothing. If you're reading, I don't know, a manual for how to use some medical device, then maybe there's a much higher level of translation quality that's expected to be able to use that device accurately. So that's kind of indicating that the real assessment of translation quality is whoever's consuming the information, and do whatever question that they're asking of the information, is that question being answered. Now, a secondary goal that we're going to talk about is using machine translation in the particular setting of professional language services where you're using machine translation to accelerate delivery. And so in that setting, it's often the case that the whoever the information consumer is or the client, they're not going to see the raw machine translation output. Instead, they're going to see the output of human translation. And you want to know whether that machine translation that you're using in the translation process is going to make your work faster, or in some cases better. We're not going to talk about the better question so much. We're going to talk mostly about the faster component. But better is an interesting question as well. And we can chat about that. I'll leave some time at the end of this for question and answer as well. So let's see. So we're going to make some assumptions, and these are based on empirical findings. And what I mean by empirical findings is that people have run controlled experiments and have observed certain phenomena that we're going to assume to be empirically valid, which means they're not true facts about the world, like acceleration due to gravity is 9.8 meters per second squared on Earth. That's like a physically verifiable quantity. This is instead a subjective evaluation. Instead, we run an experiment, we observe some results, and if we run that experiment a bunch of different times and we observe similar results, then we start to believe that this is maybe something that we can assume. So here are two things that people have observed recently, and I'll show you some results. Some of them recently, some of them over a long period of time. Human translation productivity is correlated with input machine translation quality. So what that means is the better the machine translation that you start off with, the faster you'll translate. And so this is kind of intuitively true. If you start off with a really poor translation and you have to you either reject it completely or you spend a lot of time correcting it, that's going to be slower than if the machine translation that you start off with is pretty good and you don't have to do very much to it to arrive at what you believe to be a good translation. Okay, so I'll present some results, some recent results on that. And the second sort of empirical finding that we're going to take advantage of is that some of the automatic metrics that are used in translation quality evaluation, so BLEU is the famous one, are correlated with human judgment. And what this means is that if you have, let's say, the output of two machine translation systems, and one of them is better than the other in terms of BLEU score, if you were then to run a human quality evaluation, so you would take the output of the two different systems and then give them to some human raters to decide what's better or worse, then you would observe that if BLEU says something is better, oftentimes the human raters will also find that one is better than the other. Does that make sense? So you use the automatic metric to kind of decide this is better than that, and that gives you, that's not a sort of the final verdict. Instead, then you go on to a human evaluation, and what you oftentimes observe in practice is that whatever the humans determine is correlated with what BLEU said. Okay, so that's a helpful fact because there are lots and lots of machine translation systems available on the market. Human evaluation is really time-consuming and expensive. So if we can use an automatic metric that's very, very cheap to compute, it can basically be computed instantly, to narrow the universe of systems that we're looking at from, say, like 20 down to 3, then we save ourselves a lot of time and money. And we can focus our human evaluation on those 3 systems that sort of score best on the automatic metrics, and then we have some empirical justification that actually, were we to evaluate all 20 of those systems, we'd find something like the ordering that an automatic metric gives us. Okay, so all that's to say that we're going to use automatic metrics not to say necessarily as the final verdict of what's the best system. We're instead going to use the automatic metrics to winnow the total number of systems that we're evaluating down to a relatively small number that then we can really focus on with human evaluation. Okay, so here are a couple of questions that in the process of evaluating translation quality, you could also ask. And so these are sort of ancillary questions. And then a couple of non-goals, so things that we're not going to attempt to answer. Okay, so one question that people often ask is how much human effort is required to fix machine translation. So that gets into, some of you might have heard of like edit distance. So this is saying if you have a machine translation output, how many changes does a human translator have to make to transform it into something that's acceptable? Okay, so that's a question that you can ask. That is usually more in the context of a human productivity evaluation, which we'll talk about a little bit. Here we're going to focus more on MT quality with the assumption that better input machine translation quality is going to result in less editing. Therefore, we already said it's going to be faster to translate, so there's possibly going to be less editing involved. You could also ask a question that is something like, how often are MT suggestions useful at all? And you could do that also in the context of a human productivity evaluation where you see whether a human translator chose to use an MT suggestion or not. Again, that's more getting into human translation productivity evaluations, and we're going to save that for a different talk. Here, again, we're going to focus mostly on quality. And then we could ask something like, how will these MT suggestions accelerate or improve a human translation workflow? And these are sort of related to effort and how often a human translator might use the machine translation output. Okay, so those are questions that we can start to ask once we've narrowed the universe of translation systems down to a few, that then we're going to start to expose the output of those systems to either human raters to evaluate translation quality, or maybe we're going to put them into a human translation workflow to evaluate whether there's any acceleration due to machine translation. Now, some things that we're not going to be asking as part of these evaluations are, can the system correctly translate some particular word or phrase? And so this is kind of what we most often see is in the way people look at MT systems in a human translation workflow is, I've got some content type, whatever it may be. I put some examples into the MT system and start to look at particular words and phrases to see whether it gets them right. That's not necessarily useful information, whether it gets a particular word or phrase correct for what we're trying to do here, which is we're trying to select in general a system that is going to be good across a range of content types and relative to some other system. So we're going to be evaluating larger amounts of data, and when we do that, that's going to give us some constant confidence that were we to take some other batch of data, we'd observe the same result of what this evaluation gives us. And so it sounds strange, but there are a lot of MT researchers that never even look at translation output. They just look at scores. And the reason that they do this is because looking at larger sets of data, you can start to have so many data points that you're looking at that you can start to do things with statistics to make assertions about systems. So you might be surprised to find out that people who work a lot with machine translation, they oftentimes don't ever look at the output of those systems at all. And there's a specific reason why they do that, and it doesn't have anything to do with kind of being concerned with particular words and phrases, and more has to do with the way experiments are run so that you can make large assertions about classes of systems that one is better than the other. And it's another sort of non-goal that people don't really look at with machine translation systems is, is it robust to corrupt input? So this is something like round-trip translation. If you kind of translate something to English and then you translate it back to German, from German to English with an MT system, and then English back to German with another MT system, sort of how good does the system do? That's kind of an interesting question, but it's not one that people typically look at in machine translation evaluation. Okay, so I'm going to talk a little bit about some core principles of how we're going to design this evaluation, and to sort of take people, have kind of questioned, strong opinions about machine translation quality evaluation. So instead of starting off by talking about that, let's talk about if we're going to evaluate how good somebody looks in clothes. And this is it might sound kind of silly, but it's also a subjective evaluation that people do all the time. And there's not, just like in translation, there's not one universal right answer, like what's the best set of clothes that you can wear, but you can start to evaluate how somebody looks in different types of clothing and different colors and so on. And this is often something that people do, like how good do I look in these clothes versus some other set of clothes. Those are subjective assessments, and they're the same sort of principles that we could use to answer those questions we can also use for translation quality evaluation. And this, again, this might sound really weird when you're coming from a linguistic background and you're used to staring at linguistic errors and sort of looking at errors and outputs. Instead, we're going to think about this in terms of all we want to say is one system better than another? And so we want to set up our evaluation to be able to make that statement and to know that if we were to choose a different data set, so a different type of content, and perhaps even a completely different set of people rating the output of the systems, that we'd arrive at the same answer that we do when we do our particular evaluation. So this is a principle known as repeatability. We want to have a design that's set up that if we were to run it with different people and different types of content, we'd get the same answer. Okay, so, and this is getting at kind of one of the fundamental questions or sort of goals of an experimental design, which is that you want to limit the possibility that random chance explains the outcome. So if we think about this in terms of clothing, if we were to have an evaluation where we're rating some aspects of how this person looks in these different suits, and we ask a group of people some questions to rate this particular gentleman in the suits that he's wearing, we could ask very specific questions like, you know, how good does he look in a green suit? And if you ask 10 different people, you might get 10 different answers to that question. And if you were to choose 10 more people and ask them how good does he look in a green suit, like on a scale of 1 to 10, you might get 10 different answers. So that's not a particularly good question to ask, because depending on the group of people that we ask this question to, we might get very different answers. And so we don't learn much about how good he looks in a green suit if we just ask directly, how good does he look in a green suit from a scale of 1 to 10. And so that's if we ask a question like that, there's some very high probability that just the group of people that we chose to ask that question explains any outcome that we observe. Like if a couple of them happen to say, yeah, he looks 10 in this suit, but the question that we ask isn't very good, and we take 10 different people and ask them the same question, and none of them say he's a 10, then what have we learned from those two groups of people? Well, we haven't really learned anything, because there's very high disagreement between the first group and the second group. It might be like the second group is colorblind or something, so they can't even see the green. And so there's some random variable that we don't care about that explains the discrepancy in the outcome, and so we don't really learn much from the evaluation. So that's getting really to the second point, is that if you're going to do any kind of a human evaluation, really what you care about a lot is the agreement between the different raters. And so the questions that you ask the raters who are making the evaluation, you generally want to see that they arrive at similar answers. And you can start to set that up in the way that you pose the questions, and then the way that you design the evaluation that you're going to do. So if you have what we call very low inter-annotator agreement, that's often, it's not a sign of necessarily the difficulty of the evaluation or the particular characteristics of the systems being evaluated. Instead, it's often a function of the way that the evaluation is designed and the questions that are asked. If you ask questions that generally people are going to have a hard time making consistent judgments on, then you'll have very, very low agreement between raters, and in turn, you don't learn very much from the evaluation. So maximizing agreement between the people who are involved in the evaluation is sort of related to the first objective, which is we really want to limit the possibility that random chance explains the outcome. And so the outcome that we observe of our evaluation really is just explained mostly by the group of people that we chose to participate in the evaluation. If that's the explanatory variable for what we've done, then we really haven't learned very much. Okay, so I'll give you some examples, and I kind of hinted at one of questions that you can ask about clothes that would probably yield pretty low agreement. So here's one. You could ask the question, how good does Jason look in a green suit? On a scale of 1 to 10, let's say. And so just thinking about this question a little bit, you could think about a couple different things, like how good does he look in a green suit? Well, kind of with respect to what? With respect to a different color of suit, or with respect to not wearing a suit and wearing a t-shirt and jeans? Also, how bad is, if one is, he looks really bad in a suit, how bad is really bad? If 10 is really good, how good is really good? Does that mean that a green suit is like the best possible sort of clothing that he could wear? There's really kind of a lot of, the question, there's a lot of interpretation that a rater could bring to answering this question. And we might find across a group of different people that we just get wildly different answers. And so we don't learn very much by asking people that question. Another question that we could ask is count the number of fashion mistakes in Jason's wearing of the green suit. So, if you ask a bunch of people this, you might find some people who are, kind of sloppy dressers, and they think that Jason looks pretty dapper in that suit and there's no problem. And you could have other people who are very, very particular about the way that they dress, and they could point out, well, his tie is slightly askance, and, well, I would prefer that his sleeves fell a little bit lower on his wrist and they're a little bit too high and that looks weird. Or maybe the cuff where the brakes are on his shoes, you see that they're kind of back behind where the tongues of the shoes are, and that's a problem. And you could have some people who are very, very particular about the different aspects of his wearing of this suit. And again, you don't learn very much if the way that you pose the question, some people could say, yeah, he looks fine, and some people could give you lots and lots of very different detailed answers to the question. Then you still really haven't learned much. You've just learned that they're more like, there's some people who are really particular about dressing, and there's some people that aren't. But that doesn't help you sort of explain whether Jason's wearing of the green suit is really good or really bad. Okay, so I thought we might try a little experiment where I'm going to ask you all on the call these questions, and you can write in your response, a couple questions about clothing, and you can put your response in the chat window, and we'll sort of tally up the results and see the degree of agreement between the clothing connoisseurs who are on the call. So this might be a huge failure, or it might actually work. So let's let me share my screen again. So I'm going to share exactly the screen. All right, so you should just be able to see my browser window. And now let's look at two different questions. So the first question we're going to ask is, how good does Jason look in a green suit? And if you're watching this, just open up the chat window and send me a note with a score in the range of 1 to 10 for how good he looks in a green suit, and I'll tally up these results. Okay, cool. All right, so here's what we've got. We've got 3, 6, 5, 6, 10, 5, 3, 6, 5. And one more, a 5. Okay, so actually, there's a pretty reasonable agreement here. So if I make this into a histogram and change that so the bucket size is 1. So here, let's see, that's everybody. So how many do we have? We've got 10 different observations, and so here's what the votes look like. So you have one person who thinks he looks, well, 2 people actually who thinks he looks pretty bad as a 3. Most people, I guess, thinks he looks kind of okay, either a 5 or a 6, and 1 person thinks he looks really awesome. So there's a little bit more agreement here than I would have expected. I guess most people think he looks okay. So somebody's saying, not sure we have the right screen shared. So can you see the data that I just tabulated? Okay, let me do this again. All right, so you're going to see some of your own comments here, but here now you should be able to see. Now you got it. Okay, so here's what the responses were from folks. So you know, kind of 4 5s, 3 6s, and then some outliers. Some people thinks he looks pretty awful, and one person thinks he looks fantastic. All right, so now let's try a little bit of a different question and see what the ratings look like. So the second question is, does Jason look better than, worse than, or the same as in a green suit versus a pink suit? So just write green, pink, or same, and we'll see what the results are. Same, green, same. And 1, 2, 3. Okay. We get this right. 1, 2, 3, 4, 5, 6. 1, 2, 3. Yep, looks right. Okay, so now if we do a count here, we've kind of learned something interesting. So the majority of people, 6 of the people think that he looks better in a green suit, and 3 of the people think he looks the same. But crucially, we have found out that nobody thinks he looks better in the pink suit. So we can kind of determine here that most people think he looks better in green, and fewer people think he looks the same, but not a single person thinks that he looks better in a pink suit than a green suit. So that's an interesting fact that we've learned, is that we can sort of eliminate this pink suit as the best thing that Jason could wear, because we didn't get a single vote that the pink suit is the better looking of the 2. Okay, so that's a useful piece of information relative to this, which is that okay, some people kind of think he looks okay in a green suit. Instead, now we're making a statement that's the pink suit is not the best suit that he can wear. So that's what this is telling us, and we can kind of bring that. So that's okay. So that's useful and interesting. We've kind of now asked a more specific question that's a comparative question, and we've been able to determine something that most people in this panel at least agree on, which is that he doesn't look very good in a pink suit. Okay, so that's something that now we've learned and looks like there's pretty broad agreement on. And if we were to do this a bunch of times and with different people, what we can start to find out is that people generally think that he doesn't look very good in a pink suit. Now we'd need to ask 20 people, let's say, and if this trend really started to hold up, then we can start to believe with some confidence that we can make a statement about how good he looks in a pink suit without ever actually sort of asking directly how good does he look in a pink suit, or is the green suit the best possible suit that he could wear. So let's bring that back to translation quality in the following way. One classical approach to translation quality evaluation is fluency and adequacy judgments, where you ask people to rate fluency and adequacy. So this is the target fluency of the translation. Adequacy is how faithful is the translation to the source on a 1 to 10 scale. So it's very much like asking the question, how good does Jason look in a pink suit? And in fact, this methodology was used in the early, there were a bunch of machine translation evaluations organized by the US government in the mid-2000s. And fluency adequacy was the sort of judgment regime that they used in the early evaluations. And by 2007, it was found that there was very low rater agreement. If you just ask humans to rate translations based on fluency and adequacy, there was very low agreement across human raters. And so this was rejected around 2007 for subsequent machine translation quality evaluations. Now, fluency and adequacy is still, you see it as part of some of the evaluation frameworks that are used in the translation industry. And all I'm saying about it is that people have found that these types of judgments have very low agreement if you ask a broad class of people to answer these questions. Okay, so another common approach to translation quality evaluation in industry that's not very common in research due to this rater agreement issue is using error rubrics. So you see error rubrics in kind of LQA and DQF and some of the other common evaluation methodologies in industry. These are really uncommon in doing machine translation research, and the reason for that is that counting errors is you end up with very low annotator rater agreement across a broad class of raters. And so this is like the question that we asked, or how many sort of fashion mistakes did Jason make in wearing the green suit? Some people might be very particular and sensitive to particular aspects of the way he's wearing the suit, whereas other people might not be very sensitive to those aspects. And so we don't learn very much if we pose the question in that way and we allow the human rater to get very, very specific. Now you can partly control that by specifying, trying to very carefully specify what errors people are looking for. But I think in general, you'll find that that's a task, that's kind of a proposition that's sort of futile. And the more specific you get with making linguistic judgments, the lower the sort of rater agreement that you can sort of expect. And so the right thing to do is to kind of more limit the class of errors that you're looking for. But you really need to evaluate the rater agreement for every change that you make to the error rubric. And boy, that just seems like that's going to take a long time to arrive at a sort of rubric of quality that is going to have higher rater agreement, and everybody can agree that these are the sort of errors that we want to look for, and these are very formal definitions of those errors so that everybody's looking for the same thing. Going back to kind of the clothing example, if you can think about writing very specific definitions for what tie askance means, and do the sleeves fall too high, and how do we specify what too high means, and what is the location of a good cuff break. I think it's relatively easy to imagine analogs in doing linguistic evaluation where things are subjective, so you try to write very specific requirements for them, but boy, that's really hard work. Okay, whereas what we did to arrive at sort of higher agreement was we just ask a comparative question, which is how good does Jason look in the pink suit versus the green suit? And there we started to see some agreement among folks that he looks pretty good in green relative to pink. And we didn't really have to write a specific rubric for that. It was just a comparative question that people are able to answer. Okay, so that's a lot of introductory material, and I hope that's giving you some intuition for the way that people tend to think about translation evaluation coming from the setting where we're evaluating and building machine translation systems. And if you start to think about the world this way, you'll see you make these kind of judgments all the time. I'm from the southeast of the United States, which means I really like barbecue. So this is kind of a question I'm faced with a lot, is which barbecue sauce to get. And you can think about this. There's no one right answer, but there is a systematic way to go through the barbecue aisle and pick out a good set of barbecue. And so you can apply these ideas to lots of different modes of evaluation that are subjective. So today, I'll go briefly through automatic quality evaluation. The goal of that is to winnow the universe of systems that we're going to be evaluating very quickly and cheaply. Then we'll talk about how to do a human quality evaluation. And the third part of this, if you were in an industry setting, is you probably want to do a human productivity evaluation. So that's a much longer discussion that we'll leave to next time. I want to get through automatic and human quality quickly. And the two evals that I'll go through as exemplars are one that we did recently, an automatic evaluation of 11 different machine translation systems, and I'll walk you through how that's set up. And then I'll explain the sort of Google neural machine translation human evaluation that got a lot of media attention last fall. And we'll talk about how that was set up too. Okay, so options for evaluation, we kind of talked about this a little bit. You have automatic and human evaluation. Again, we're not gonna sort of focus on translation productivity right now, but I'll make one statement about that in the next slide. And we kind of have two options. We have automatic and human, and we have small text sample and large text sample. So the worst kind of setting is automatic evaluation with a small amount of content. Why don't you do that? Because, well, you're not really evaluating enough stuff to draw a conclusion. So when you're doing an automatic evaluation, usually you want to evaluate a reasonable amount of stuff, where reasonable amount is about 2,000 segments, between 1,000 and 2,000 segments. So you can do a systematic comparison of systems against reference translations, and the outcome of this is going to be a pretty reliable measurement, and that gets into questions of statistical significance. But the takeaway here is you can make statistical statements about what's better, one system being better relative to some other system, and that's really what we want to do with the automatic evaluation. With human evaluation, the situation's kind of different. We'd love to do the same thing with human evaluation and do a large content sample. The issue is that's pretty expensive and time consuming. So what we usually end up doing with human evaluation is we sample a smaller set of content and for human evaluation after we've done automatic evaluation to confirm what we've learned from the automatic case. So what I'm going to walk through is we're going to do an automatic evaluation of a large content sample, and then we're going to talk through how we would then take a subset of that large content sample and do human evaluation. And so this is going to be the fastest and cheapest way to evaluate translation quality. So for the automatic metric, we're going to use BLEU, which most people know about, and the intuition behind it is that it is the average overlap between a machine translation output and a human reference. So you get the output of the MT system, you have some human reference that some human has created, and you're going to measure how similar the machine translation output is to this human reference. Now, there's some technical critiques that you can make of this style of automatic evaluation. Probably the most obvious of which is that there's more than one possible correct translation for any source sentence. That's certainly true. One way around that is to use multiple reference translations. That's expensive, so oftentimes people don't do that. But so another way to get around it is just to use a very large sample of content where you have lots and lots of human reference translations. And that's more the solution that we're going to follow. Okay, so really the question that we're asking is what proportion of the automatically generated phrases also appear in the reference translation? Okay, now why are we going to use BLEU? There are other ones that you could use, TER, which is a net distance-based metric, Meteor, which includes some syntactic information. Well, the reason that BLEU persists is really there's just one reason. Well, there's actually kind of two. So the main one that's interesting is that people have found in lots of different evaluations that it correlates well with human quality judgment. And by that I mean you run an experiment like what we're going to do, where you evaluate a bunch of different systems, you get some ranking in terms of BLEU, and then you're going to do a human evaluation, and do the humans arrive at the same ranking? And this experiment has been run lots and lots of times, and people find that BLEU generally gives the same sort of ranking of systems that humans give. and at least as good a ranking as any of the other metrics that people have come up with. So BLEU is super cheap to compute. It's very easy to understand. It has some other properties that are really nice. It doesn't, it's weird to think about, and then it doesn't incorporate any semantic or syntactic information, but the crucial property of it is that people have found that it correlates well with human quality judgment, and that's really what we care about in evaluation. So there's a paper that you can read, and I'll put some references in the slides so you can go read some of these papers if those interest you. But that's the main reason I think why BLEU persists, is that people find it correlates reasonably well with human quality judgment. Now, there's some interesting work recently on correlating BLEU with translation time. So this is work, there's work on this going back to 2009, but the most recent and best work, I think, just came out last year. And so what was shown here was for English to Spanish, some translators were hired on prose. And these two researchers, one of whom is Philip Kuhn, who some people might know as the person who's behind Moses. He's a professor at Johns Hopkins University. What they did was they prepared 9 different machine translation systems of various levels of quality in terms of BLEU. And you can do that by limiting the amount of training data. So like less training data, you're going to get a worse system. More training data, you're going to get a better system. And then they asked people to post-edit with the outputs of these systems. And so what you see here, and the numbers are kind of small, I've copied this directly from the paper. On the horizontal axis, this is BLEU increasing. And on the vertical axis, this is translation time decreasing. So 5 seconds average per word down to, I think this is seconds, yeah, down to 4 seconds per word. And what you see is this very nice trend line is this MT system is the worst in terms of translation quality, and also post-editing time is slowest. All the way down to the best system in terms of BLEU is the fastest in terms of post-editing time. So the result here was that for every 1 point increase in BLEU, you get about a 0.16 second per word decrease in translation time. So again, BLEU can be used to sort of make general statements very quickly about systems. These are not conclusive statements. These are not like sort of physical facts about the world, like what's acceleration due to gravity, but it can be used to very quickly and cheaply winnow the world of systems that you're looking at. So, if we were looking at some different systems for post-editing, and we saw that, this MT system gives 24 BLEU and this one gives 31 BLEU, we could, with some reliability, expect that were we to run an actual post-editing experiment, that this system would result in faster translation time. And we could do that without actually running the experiment. We could just do that very quickly at the beginning to winnow the universe of 30 systems or whatever down to the couple that are really good, and then we could spend the time and effort to do the post-editing evaluation. Okay. So what we're going to do in 2017, there are many machine translation options available. It's infeasible to evaluate all of them. So the efficient approach is we'll use automatic evaluation to select a few candidates, and then we'll confirm those candidates with human judgments. Okay, so I'll just go briefly through a couple evaluations now. This is the labs evaluation. This is one that we did in December and January of this year. And so this is the way the experiment is set up, and then I'll take you through the results, and we'll interpret the results tables together, and then we'll move on to human evaluation. So the training corpus, or the evaluation corpus that we used was a set of press releases from 1997 to 2013. When you're thinking about data, of course, what you want to do ideally is you want to evaluate content that's representative of what you're going to be doing in your translation setting. So if you're a business, you might want to choose content from your business, and crucially, you might want to think about evaluating different kinds of content. Like if you have software support content, you have legal contracts, you might want to have a little bit of both and put those in your evaluation. Here we chose this data set because it's public and everybody can download it and do experiments on it. It's a good idea to choose different language pairs. So I think one thing that people commonly do is they think that, well, one system might be better for English to French and another system might be better for English to German. That's kind of often that can be true, but if you set up your evaluation correctly, I think what you'll often find is that some systems are just better across all language pairs than others. And so, you know, when you think about this from the perspective of somebody who's creating a machine translation system, the goal for them is to make it good across language pairs, not just great for one specific language pair. So if you're seeing artifacts of one language, you know, one system being better for one language pair than another, that might be an indication of your evaluations not quite set up correctly, because oftentimes what you find is the same system is good across language pairs. So it's good to test two reasonably different language pairs. In this case, English to French is one that's typically pretty easy for MT. English to German is one that's pretty hard. A couple different public systems that we'll evaluate and a couple different configurations, and we're going to use BLEU. Okay, so here's the English to French results. So on the horizontal axis are the different systems, and on the, or excuse me, on the vertical axis are the different systems, and on the horizontal axis are the BLEU scores. And so what you see here is a couple different setups of the systems. So Microsoft versus Microsoft adapted. This is when you add a little bit of TM data to train the baseline Microsoft system. And so you can do that with Microsoft Translator Hub. Likewise, you can do that with SDL Language Cloud. Then you start to see some of the new neural offerings from some of these vendors. So Microsoft now has a neural system. You can't adapt their neural system, so this is just the baseline neural output.